Today, we are going to talk about fundamentals of cryptography. This lecture introduces the essential concepts, techniques, and algorithms used to secure data, focusing on how encryption, decryption, and cryptographic protocols protect information from unauthorized access and tampering. Before starting this lecture, I want just to open a little, like, let's say, parenthesis about my teaching strategy for this course. So I'm working, let's say, hard to use AI, to use like a lot of editing, like to illustrate things visually and so on. One of the best approaches that I recently used was like using short videos, and many of you appreciated that. I'm very thankful. So, as a plan of action for this week, we will continue using, let's say, short videos, and also I am going to use my own recorded voice. Okay, so by the end of this module, you are going to learn a lot, let me say, and mainly you should be able to define cryptography, to describe hash, symmetric and asymmetric cryptographic algorithms. You will be also able to list the various ways, let me say, in which cryptography is used and explain different cryptographic limitations and attacks. Here we go. So we're going to start our first part with cryptography. So let me say that I would love to start this chapter, which is fundamentals of cryptography, by introducing a new concept, which is steganography. So, steganography is closely related to the concepts of secrecy and data protection, which are key parts of cryptography. So, while cryptography focuses on encoding messages, so only authorized users can understand them, steganography hides the existence of the message itself. Instead of openly writing the message, steganography secretly embeds it, let's say, inside other files like images, audio, or videos in part of the file like that aren't visible, or let me say that aren't used, okay? Such as extra space in the file's metadata or in areas like the file's header, for example, okay? So this makes it much harder for someone to detect the hidden message unless they know mainly exactly, let me say, where to look. So both cryptography and uh, steganography aim to keep information secure, but cryptography focuses on making the message unreadable without a key. So while steganography like focuses on hiding the messages inside existence itself, let's say entirely. So together they offer stronger protection for data by making the message, I would say, both unreadable and untraceable. Cryptography is the practice of transforming information so that its meaning cannot be understood by unauthorized people. Okay, this is the main definition. So if we are working on the fundamentals of cryptography, so we are mainly working on different ways and practices to transform like the original message or information, let's say, in a way that makes like it ununderstandable by like unauthorized users or people. Okay, so this is done by scrambling the message in ways, let's say, that make it unreadable without a special key. Okay, one method of cryptography is transposition, where the letters in the message, let's say, are arranged in different order. Okay, if we have the message, it contains several words, and we play with the letters of that words. Okay, there are different methods. Like another one, for example, is substitution. And substitution mainly is where one letter is replaced, let's say, with another letter or with another symbol, okay? So these techniques help protect information by making it difficult for anyone to understand the message without like the correct methods like to decode it, okay? So this is the main idea or overall definition, let's say, of cryptography. Now let me introduce encryption. Encryption is the process of turning normal text into scrambled message so that only authorized people can understand it. The opposite process, where the, let's say, scrambled message is turned back into the original text, is called decryption. Okay, so we have now encryption and decryption. Now, let me introduce some like key terms in cryptography. You will hear a lot about plain text. Okay, so we have plain text. Plain text is the original encrypted text, okay? And mainly the plain text, which is the original encrypted text, is ready to be scrambled or the result, let's say, after it's been unscrambled. Okay, so whatever we can read, whatever is like mainly the original text, is that the plain text. Okay, and no matter what is like if we're going to later scramble it or if we are already like and scramble it. Okay, so next we have a cipher text. Okay, cipher text is now the scrambled, which is the unreadable message. Okay. Um, this like how we make it unreadable, it's the way that we are creating, let's say, a new version of the message through encryption. Okay, and we have also now clear text. Clear text is the normal, let me say, unencrypted text that doesn't need any protection. Okay, so these terms now help us introduce like uh, to cryptography fundamentals and understand how information is hidden and recovered during encryption and decryption. Let's keep talking about cryptography, which is a way of hiding the meaning of a message. When we start with a normal readable message called plain text, we use a special process called a cipher. This process uses math in order to scramble the message into something unreadable, which is called ciphertext. Now, to scramble and unscramble the message, we need a key. And the key is kind of a secret code, let me say, that helps turning the scrambled message back into the original form. Okay, so the most important part of cryptography is keeping like that key secret. Okay, and if someone else gets the key now, they can easily read the message. Okay, and this is a big problem that we want to avoid in cryptography. So always remember, the key must stay private in order to keep the message safe. Let's take a closer look at how cryptography works in order to hide the meaning of a message. Imagine you have a confidential memo, which is, let's say, plain text. This is the original, like readable message, plain text. Okay. To keep it safe, we use an encryption algorithm, which is like a secret formula that scrambles the message into ciphertext, turning it, let's say, into something unreadable. This scrambled message is then sent to a remote user, and once the user receives it, they can use the same key in order to turn the ciphertext back into plain text or the original message, right? Okay, so the idea is that we're turning the ciphertext into the original message, also called plain text. This process ensures that only the right person with the correct key can read the message and understand its meaning. Let's discuss now the benefits of cryptography. Okay, it has several important security benefits. First one is confidentiality. Like this makes sure that only the right people can see the message. We have also integrity, and integrity ensures that the information stays correct and hasn't been changed. Cryptography also ensures authentication, and this helps us verify who sent the message, okay? So we know it's really from them. We have also non-repudiation, and this means that we can prove that the user actually did something, like sending the message itself, for example. It ensures also obfuscation, and this is mainly a fancy word for making something unclear or hard to understand. And lastly, like security through obscurity. Security through obscurity is the idea that a system can be secure. So, like, if no one knows how it works, or let's say has access to it, okay? And all these benefits now work together to keep our data safe and secure. Thank you for watching. And in the next video, we are going to discuss the different cryptographic algorithms.